Good morning, everyone. I'm excited to have you all here as we take a deep dive into a critical topic enhancing security of MySQL connections using SSL certificates. In a world where data breaches and cyber threats continue to pose challenges, ensuring the security of our database connections is non negotiable. That's where SSL certificates come in as a powerful tool, adding an extra layer of protection to your MySQL connections. My name is Maha Lakshmi, and I'm truly excited to be a part of today's webinar on enhancing the security of MySQL connections using SSL certificates. In my role as a database engineer at Mydbops, I'm fortunate to have the opportunity to not only apply my expertise but also share it. I have developed a profound interest in MySQL and the vast ecosystem that surrounds it, and had the privilege of immersing myself in topics like InnoDB internals and performance troubleshooting. Let me share some insights about Mydbops, the company I'm proud to be a part of. Established in 2016, Mydbops specializes in delivering exceptional services on open source databases. With a dedicated team of 85 experts, we have had the privilege of assisting over 800 plus customers. More than just that, we are an AWS partner, a PCI certified and ISO certified organization. Let's outline the structure of our webinar, focusing on enhancing security of MySQL connections using SSL certificates. First, we will lay the groundwork by understanding the importance of SSL certificates in securing MySQL connections. Next, we will delve into the inner workings of SSL, demystifying the mechanisms that ensure secure data transmission. Then, we will explore the tangible benefits of enabling SSL in MySQL, understanding how it contributes to enhanced security. Moving on, we will navigate the landscape of SSL certificate types, helping you make informed decisions about the right fit for your setup. After that, we will take a journey through the evolution of SSL in MySQL ecosystem. Finally, I will guide you through practical steps to enable SSL connections in MySQL 8.0. Let's now move over to our abstract, where we will explore the core of our topic in more detail. Secure Sockets Layer, commonly known as SSL, is an industry standard cryptographic protocol in the world of data security. It's the go-to solution for bolstering the security of network connections between client and server machines. Enabling SSL or TLS results in data encryption for both inbound and outbound transmissions within databases, guaranteeing secure remote connections. Let's now transition to our next slide, where we will delve into the intricacies of how SSL works. First, client initiates the SSL session. In response, the server presents its encrypted public key or certificate. At this point, it's like the server presenting a form of identification that validates both its identity and its ability to engage in secure communication. Upon receiving the certificate, the client examines it. If everything checks out, the client proceeds to generate a unique private encryption key. To truly secure the connection, the client encrypts this key using the server's public key. It's like putting the key inside an envelope and that the server only can open. The server, the only one with the corresponding private key, decrypts this message, retrieving the encryption key. Now, armed with the encryption key, both client and server are ready to converse in a secret encrypted language. Data exchanged between them is safeguarded by this encryption, ensuring its confidentiality. This is the complete cycle of SSL. Now that we have grasped the mechanics of SSL, let's shift our focus to another critical aspect, the benefits of enabling SSL in MySQL. So without further ado, let's move on to the next slide and explore the advantages that come with implementing SSL in your MySQL environment. Enabling SSL secure socket layer encryption in MySQL offers several important benefits that enhance the security of your database connections. Here are some advantages of using SSL in MySQL. Data confidentiality. SSL encryption ensures that data transmitted between the MySQL client and server is encrypted and secure. This prevents eavesdropping and unauthorized access to sensitive information such as usernames, passwords, queries, and data. Authentication. SSL certificates are used to authenticate the identity of the MySQL server to the client. This helps prevent man-in-the-middle attacks where an attacker impersonates the server. Clients can verify the server's authenticity using the certificate. Secure remote connections. SSL allows you to securely connect to a MySQL server over untrusted networks like the internet. This is our main goal and crucial for remote database administration, replication, and remote access scenarios. Secure replication. MySQL replication involves transmitting data between source and replica servers. Enabling SSL for replication ensures that this data is secure during transmission. Client trust. By providing secure connections through SSL, you enhance user trust in your application and database, as users can be confident that their data is being handled securely. Flexibility in certificate choices. Depending on the level of trust required, you can choose to use self-signed certificates or obtain CA-signed certificates from trusted certificate authorities. With a solid understanding of the benefits of SSL in MySQL, it's time to uncover the various types of SSL certificates available. So let's transition to our next slide and delve into the realm of SSL certificate options. SSL certificates generally refer to X509 certificates. These are just digital documents that verify the authenticity of a server. We had mainly categorized the SSL certificates into three types. The first type comes self-signed certificates. These certificates are generated by the server itself using tools like OpenSSL. We had three system variables that control the generation of the required RSA or SSL files. The first is auto-generate search and SHA-256 password auto-generate RSA keys. And the third variable is catching SHA-2 password auto-generate RSA keys. And the second type comes in SSL certificates is CA signed certificates. These are also known as publicly signed certificates. These are, as name suggests, these are signed by a publicly trusted certificate authority like Let's Encrypt Commando. And we had the last type as wildcard certificates. These are same as CA signed certificates, but where in a scenario we had multiple IP addresses with the same series, we can use a wildcard certificate, a single certificate which is authorized by certificate authority to secure the connections. As we progress through our exploration, the evolution of SSL to our next slide and take a journey back in time to understand how SSL has evolved within the realm of MySQL. MySQL supports encrypted connections between clients and server machines using the TLS protocol. Since back we are talking about SSL, TLS is sometimes referred to as SSL. TLS stands for Transport Layer Security. Whereas in MySQL, it's not actually supporting the SSL protocol for encrypted connections because its encryption is weak. This is how SSL has evolved with respect to the MySQL versions. In MySQL 5.7 environment, the versions which are less than 5.7.35, we had the TLS protocol support for TLS version 1.0, 1.1, and 1.2. Whereas in versions which are greater than or equals to 5.7.35, we had the TLS protocol supported 1.2 and 1.3. Coming to 8.4 environment, in MySQL Server versions which are less than 8.0.15, we had a support of TLS version 1.0, 1.1, and 1.2. In versions which are greater than or equals to 8.0.16 and which are less than or equals to 8.0.25, we had the TLS version support 1.0, 1.1, 1.2, 1.3. And till date, from which are versions which are greater than or equals to 8.0.26, we had the TLS protocol support version 1.2 and 1.3. Let's move on to see how all these concepts we have discussed come together in a real world scenario. In a MySQL 8.0 versions, SSL is enabled by default, which is not the same with MySQL 5.7, where we have to enable the SSL if needed. MySQL client will automatically attempt to connect using SSL if it is supported by the server in case TCP or IP connections only. If you want to secure or encrypt the specified remote user connections, you have to create the specific user or modify the existing user using require SSL clause along with the create user or alter user statements. Also, if you want to secure all the remote connections, you have to add the require secure transport option in the config file. This allows all connections to be made either with SSL or with a local Unix socket. We had different SSL modes which determines the level of security and verification used during the connection process. In other words, it's a way to customize the behavior of the SSL or TLS protocols to align with your specific security requirements. We had disable mode. This mode disables SSL or TLS encryption for the connection. So here the data would be transmitted in a plain text. And we had preferred mode. In this mode, the client attempts to use SSL or TLS for the connection. If the server is supporting TLS or SSL, the connection is encrypted. If not, the connections proceed without encryption. But it's not same with the next mode, which is required. With this mode, the client requires an SSL or TLS connection. If the server doesn't support SSL or TLS connection, the connection itself is not established. And we had verify CA and verify identity modes. When the client connects using SSL or TLS and verifies the server certificate against a trusted certificate authority. If the verification is okay, then the connection is established. If the verification is failed, the connection is aborted. And in verify identity, this mode is similar to verify CA, but it also checks that the common name in the server certificate matches the host name of the server to prevent man-in-the-middle attacks. And we can secure replication using SSL. It allows, if you use replication using SSL, it ensures that data transmitted between the replication source and replica is encrypted. SSL encryption prevents unauthorized access and eavesdropping, maintaining the confidentiality of sensitive information during replication. And while SSL-enabled replication utilizes digital certificates and private keys for authentication, this is what certificate-based authentication means. This verifies the identity of both the source and replica servers, reducing the risk of man-in-the-middle attacks. Certificates provide a secure handshake process before replication begins. So for that, you have to go to the source server, stop slave, and you have to reset the replication using the change master command, which you can see here in this slide. You have to give master source SSL CA and source SSL certificate and source SSL key with this change master command. Now I will show you how we can create a user to secure remote connections, and I will show a small demo on this. Let me reshare my screen. This is my MySQL server. It is having 8.0.33 version. And this is my client server having the same MySQL version. By default, all the server and client certificate keys are located in the MySQL data directory. If you want to see those files, you have to list the .pem files in the MySQL data directory. Here I am listing the files in the MySQL server data directory using ls command. These are all the certificates and key files, as I said, which will be located in the data directory by default. We have ca-key.pem and ca.pem files. These files contain the certificate authority, CA key and certificate respectively. The CA certificate is used to verify the authenticity of other certificates in the system. It's the root certificate in the certificate chain. Server key.pem and server set.pem. These two files contain the private key and certificate for the MySQL server. The private key is used to decrypt incoming data encrypted with the public key, and the certificate is used to verify the server's identity to clients connecting to it. And later client key.pem and client cert.pem. These files contain the private key and certificate for MySQL clients. Similar to the server key and certificate, these are used for encryption and authentication when clients connect to the MySQL server. And we have private key.pem and public key.pem. These files contain the private and public keys for MySQL secure connections feature. This feature allows encrypted connections between the MySQL server and clients. The private key is used by the server to encrypt the data sent to the client. And the public key here is used by the client to encrypt data sent to the server. As we discussed in the presentation slide, MySQL will automatically attempt to connect using SSL if it is supported by the server in case of TCP/IP connections. We'll see. I have connected to the MySQL server using a IP. This is my client mission and I'm connecting to the MySQL server using a user which I have created in the server already. I have created this web user 1 for testing purpose with require SSL clause. If we want to secure all MySQL connections for a specific user, you have to create the user like this, create user statement along with require SSL clause. And coming to connections, if I connected from a local host via Unix socket, SSL is not being used. Here, SSL not in use. I can connect to MySQL again, and my connection is from localhost via Unix socket. Even SSL is enabled by default in my server. SSL is not being used. So we can check that using the show variables like SSL command. I will show you. If you see have open SSL, have SSL were set to yes, which means that SSL was enabled in this server. But anyhow, my connection is from a local host via Unix socket. The SSL is not being used. Whereas from here, if you see I have connected the MySQL server using a IP. Here SSL is being used. Cipher which is being used is the highlighted one. And we have discussed different modes. We will check each mode and while connecting to the MySQL server. And the first mode I am checking is disabled. Here, for this user, I have created this user using require SSL clause. So it won't accept a connection because disabled disables the encryption as we discussed that. And next mode is preferred. Here connection is accepted because whenever SSL is supported in the server, the connection will be accepted. Here you can see SSL cipher is in use. If the server doesn't support SSL, if the MySQL server which I had doesn't support SSL, it has the connection will not be encrypted, but the connection would be success in this preferred mode. If you don't specify any mode while connecting to the MySQL server, the default mode would be preferred. And the next mode is required. Here the connection is accepted because the MySQL server supports SSL. If it's not supported, the connection would be aborted. And we have verify CA and verify certificate modes. As we already added the client certificates in the client machine, so verify CA, it is accepted. The connection would be accepted here. But if you see the verify identity, it will throw a error because it will check other level of authentication, like a common host name is there in the server certificate and in the host name. So these are the different SSL modes we have, and this is for user level restriction or secure encryption. But if you want to globally, if you want to secure all the user connections in MySQL, you have to use the secure transport, require secure transport option. You have to enable that in the config file. And this is all about the demo part. And if you have any questions regarding presentation or demo, you can drop them in the chat box. We would be happy to answer. Thank you.